This video will introduce the core concept of calculus and explain some of the terminology. Calculus is useful when we have two quantities varying in relation to each other. In this video, we will focus on the example of distance varying with time. Let's think about a moving car. Remember from school that speed equals distance over time. If you wanted to calculate its speed, you'd measure the distance it travelled and divide that by the time that passed whilst travelling. For instance, if you travelled 60 kilometres in an hour, your average speed was 60 kilometres per hour. Another way of thinking about distance is the change in the car's location. In mathematics, we often use the Greek capital letter delta to represent change. So if we call position x and time t, then speed is equal to the change in location over the change in time, or delta x over delta t. This is just the same old speed, time and distance formula you've used in school. So far, so good. But we usually don't want to measure speed over the last hour or minute. We want to measure speed now, at this instant. The traditional speed equals distance over time formula only gives us the average speed over some period of time. It does not calculate the speed now, at this very moment. This is where we turn to calculus. Calculus tells us that we need to imagine calculating the speed over smaller and smaller steps in time. So let's say over the last half hour, then the last minute, the last second, the last hundredth of a second, and so forth. Our speed is still change in position divided by change in time. But as we calculate it over smaller and smaller steps, both the change in position and change in time get smaller. And as we look at smaller and smaller steps in time, the speed we are calculating is getting closer and closer to our speed at this instant. Now imagine continuing until the change in time and change in position become infinitesimally small. Now this speed, this infinitely small change in position divided by the infinitely small change in time, is our speed this instant. To represent that our changes are now infinitely small, we replace our capital Greek deltas with a little d. So, instantaneous speed equals dx over dt. Calculus is all about this process of imagining the changes in distance and time getting smaller and smaller until they become infinitesimally small. In calculus, d means an infinitesimally small change. In our example, dt is a tiny step in time and dx is a tiny step in position, but it could be anything. There are two main types of calculus: differential calculus and integral calculus. This video is mainly based on differential calculus. The next few videos look at each of these two kinds separately.